Study of an upflow anaerobic sludge blanket reactor in the treatment of slaughter wastewater. Abstract: the wastewater discharged by the slaughterhouse was characterized mainly by the high biochemical oxygen demand, high suspended solids, and complex mixture of fats, proteins are requiring systematic treatment before disposal. This study was carried out to examine a lab-scale upflow anaerobic sludge blanket reactor performance to treat slaughter wastewater under varying operating conditions. pH, 7.1 to 7.8, total suspended solids, TSS, 900-1500 mg/L, total dissolved solids, TDS, 1600 to 3000 mg/L, chemical oxygen demand, COD, 3000 to 5000 mg/L. The reactor was running at varying OLR, 0.025, and HRT, 7.00, 11.00, 15.00, 19.00, 23.00 hours, at a temperature of 29 to 35 degrees Celsius. The maximum total demand for the chemical oxygen removal efficiency of 82.83% was achieved at an organic loading rate of 0.015 kg/cod/m2/day and at the hydraulic retention time of 23 hours. Keywords: slaughter wastewater, Uasb reactor, COD, OLR, and HRT. Introduction: slaughterhouse wastewaters were considered by different European legislation as very contaminating, Tritt and Schuckart, 1992, due to their composition, characterized mainly by the complex mixture of fats, proteins. Processing a chicken for human consumption requires 10-12 L of water, so overall water consumption for the poultry processing plant is considerable. 60% of the water is converted into wastewater with a value of pH between 6.1 and 7.1, a biological oxygen demand, BOD, between 4512,000 mg/L, and a large percentage of solids, mostly clotted of blood, more than 40% in volume, with a high fat content, Mercado, 1995. The rest of the wastewater is lost in the process through runoff. In most slaughterhouses in Tamil Nadu, useful blood collection, separation of manure, or effluent treatment methods were not practiced, and incredibly complex effluents are discharged into land or water. Surface and groundwater pollution, in addition to odor, fly, and mosquito nuisances, are posed by these practices. Most of this wastewater is treated physico-chemical, requiring large quantities of chemicals and energy to dry the effluent and generating 20 grams of sludge per liter of water. The deposition of the sludge is difficult, thus limiting the use of this technique. A better option to reduce the generated biosolids might be anaerobic digestion using upflow anaerobic sludge blanket reactors, Uasb, Spies, 1983, Young and Dahab, 1983, Young, 1991. In the Uasb process, the anaerobic bacteria convert organic material into methane, carbon dioxide, and biomass while purifying the wastewater, Del Neri et al., 2001. Uasb systems were known for their high volumetric treatment rates, good CH4 productivity, and low sludge production, making their process economically and technologically attractive. Del Pozo et al., 2000. As mentioned before, this study's objective was to evaluate the performance of the upflow of anaerobic sludge blanket reactor in the treatment of slaughterhouse wastewater. The experiments were carried out in a Uasb reactor were processed to study their influence on the organic loading rate, OLR, and hydraulic retention time, HRT, in slaughterhouse treatment of wastewater. Related work: a wide range of the organic loading rates and hydraulic retention times have been reported in the literature for Uasb reactors, depending on their substrate used and the microbial community's quality. In this study, the removal efficiency of COD for varying OLR, 0.013, 0.023, 0.037 kg/cod/m2/day, was studied. Initial reduction with the increased OLR was moderate, and it tends to increase with the decrease in OLR. The effect of varying H.R. was investigated. Removal efficiency was optimum at the high retention time. The decrease in the efficiency of reducing the HRT, despite increasing the turbulence of reactor, is that contact time of the wastewater with the sludge granules will be decreased, so less organic matters was utilized. Experimental setup of bench scale continuous of upflow in anaerobic sludge blanket, Uasb, reactor made of fiberglass was used in this study. The reactor had an internal diameter of 11.5 centimeters and a total height of 98 centimeters, resulting in a total volume of 10 liters and a working of 5.4 liters with a gas headspace of 1 liter. The reactors were fed with the substrate using the peristaltic pump, model, PP30, Michelins. A peristaltic pump can maintain the straight flow of rate in a range of 2 ml/h to 10 L/h, present with the timer and LED display for the flow rate of the function and time. 5 sampling ports were installed along with the length of the reactor. Biogas produced from the reactor was collected by the water displacement method using a Marietta bottle. The operating temperature of reactors was in the mesophilic range of 29 to 35 degrees Celsius. The experimental setup of the Uasb reactor was shown below. Influent wastewater. For this study, the primary source of the wastewater was collected from the local slaughterhouse in the market in 2 different locations, Chidambaram, Cuddalore, and Tamil Nadu. Wastewater was consisted of effluent from the combination of several stages. It included blood from the killing operations, wash waters from the stomach and the intestines. The addition of nutrients were not deemed necessary since the wastewater characteristics indicated an adequate concentration of the essential proteins and trace elements. No dilution or recycling feed was made in the beginning or at any of the study phases. Chemical analyses such as pH, BOD, TSS, VSS, TDS, and COD to determine the wastewater quality parameters, were conducted according to standard methods, APHA, 2005. Experimental methodology. For the startup, the bottom of the reactor was filled with the anaerobic sludge taken from the wastewater treatment facilities of Annamalai University and then fed continuously with the screened domestic wastewater and are allowed to stand for 15 days. Throughout the study, the reactor was operated at a room temperature of 30 plus or minus 2 degrees C. After stabilization, synthetic wastewater was used for an experimental study to standardize the experiment. The synthetic wastewater was prepared by using the dry fish powder. The synthetic wastewater were fed into the reactor, and it was studied for cod removal, as % of cod removal efficiency under varied organic loading rates, OLR, and hydraulic retention time, HRT. The averaged influent of cod applied over system was 2789.4, 3770, 4738.8, 5741.6, 6354 and 6818 mg/L for the varied HRT, 7.00, 11.00, 15.00, 19.00, 23.00 HRS, and OLR, 0.013, 0.023, 0.037 kg/cod/m2/day. Under each operating condition, influent and effluent of cod and amount of gas were observed using the standard method of analysis. The average values of biochemical characteristics of slaughter wastewater effluent are listed in. Results and discussion. After the Uasb reactor was stabilized, synthetic wastewater was prepared and used for the experimental study. The experiment was conducted to evaluate the Uasb system in the terms of cod removal. The reactor ran continuously for 45 days. The average influent of cod was prepared 2789.4, 3770, 4738.8, 5741.6, 6354 and 6818 mg/L. Initially, cod removal efficiency were poor. After some period of the reactor reached the steady state condition and removal condition efficiency was improved 82.68%. The graphical representations to assess reactor performance for different operating conditions was drawn, using the observed values. Cod removal of efficiency for varying OLR, 0.013, 0.023, 0.037 kg/cod/m2/day, was shown in Fig 2 and Fig 3. And cod removal of efficiency for varying HRT, 7.00, 11.00, 15.00, 19.00, 23.00 HRS, was shown in Fig 4 and Fig 5. It shows the treatment of performance of reactor as percent removal under the varying OLR, kg/cod/m2/day. And it depicted the understanding of the all different influent cod concentration. It was drawn on reactor's performance in the terms of percent cod removal under varying hydraulic loading rates, HRS. The cod removal of efficiency for varying HLR, 0.25, 0.125, 0.082, 0.062, 0.05 cubic meters/m2/day, was shown in above Fig. 6 and Fig. 7. And the cod removal of efficiency for varying HRT was shown in below Fig. 8. Conclusion. The Uasb is the experimentally concluded to offer the maximum demand of chemical oxygen removal for efficiency of 82.83% was achieved at the organic loading rate, OLR, of 0.015 kg/cod/m2/day and at the hydraulic retention time, HRT, of 23H. Hence, it can be studied that Uasb is the credible alternative to reach the reusable standards for treating the slaughter wastewater effluent streams.